First we need to factor the denominator here. We have to have a plus times a minus to get a negative on the end. And we're looking for two numbers whose product is 88 and whose difference is 3. 8 times 11 does the trick here. And the big number, the 11, goes with the negative because the middle term is negative. And so, wondering, when is this larger than or equal to 0? So we need a line for each of these factors involved in this. A line for x minus 5, for x plus 8, for x minus 11, and for the quotient. Also notice that these two are from the denominator. Both those factors are in the denominator. Okay, so here's a line for each of these. And where are all these equal to 0? To begin with, negative 8, this one's 0, so that'll be the smallest. The number on the left will be negative 8 here. Then comes 5 and then 11. So let's make this 5 and this is 11. And now we can see that when x is equal to 5, x minus 5 is 0. If x is bigger than 5, it's positive. And if x is less than 5, it's negative. X plus 8 is equal to 0 when x equals negative 8. If x is larger than negative 8, this binomial is positive. Less than negative 8, x plus 8 is negative. X minus 11 is 0 when x equals 11. And if x is larger than 11, then x minus 11 is positive. Otherwise, it's negative. So now we have a negative times a negative divided by a negative divided by a negative. It's like a negative times a negative times a negative is a negative. A 0 in the denominator makes this undefined because you can't divide by 0. A negative times a negative is a positive. 0 in the numerator makes everything 0. Positive times a negative is a negative. And a 0 in the denominator again, undefined. Positive makes a positive. That last line then tells us when the quotient is positive, when is it negative, when is it 0. And we need to know, where is it positive? Positive or 0? That's what we're looking for. So we can now graph the solution set. So we need a negative 8, we need a 5, and we need an 11. So we'll put a circle around each of these. Notice there's a 0 at 5, so let's fill in this one, because this one is part of the solution. This is a 0, but those are not. Okay, now the positives are then between negative 8 and 5. So we'll shade in the solution set here. And also everything to the right of 11, so it's everything to the right here. Now we can graph, or put this in interval notation. This is the graph of the solution set. Negative infinity lives to the left of the number line, positive infinity to the right. So we can write this as the interval from negative 8 up to 5, including the 5, but not including the negative 8, union with the interval from 11 to infinity, not including 11, or infinity. And in set builder notation, set of all x such that x is between negative 8 and 5, including the 5, or x is bigger than 11. So these are three ways of expressing the solution set to this rational inequality.